Our last step here is looking at the equations for lenses. Now this is very similar to what we did for mirrors. Basically, our distances are all measured from the center of our lens. Positive distances are always going to be real, where negative distances will be the virtual. Positive image heights are going to be erect or above the principal axis, and negative image heights will be below the principal axis or facing downward, okay, inverted. Converging lenses have a positive focal length, and diverging lenses have a negative focal length. So this last part here is some of the most important things to look at. So anytime it's diverging, it's going to be a negative, and every time it's converging, it's going to be a positive. Because on diverging lenses, if we think about it, our distance is going to be on the same side as our image. Whereas converging lenses, the focal distance will be on the opposite side of the image. So let's take a look at our first example here. I have 2.5 centimeter object is placed 10 centimeters from a diverging lens. The focal length is 5 centimeters. Determine the image distance, the height attributes using the thin lens equations. Verify your answer. So let's take a look at this here. First, we know my height of object. So first I know my height of object is equal to 2.5 centimeters. We also know my distance of object is equal to 10 centimeters. Okay? I know my length is equal to 5 centimeters, or my focal length. So my focal length is equal to 5 centimeters. I am trying to figure out what is the distance of the image, and I'm also trying to figure out what is the height of the image. So let's start off here trying to find the distance of the image. I know the reciprocal of my distance of object plus the distance of the image, the reciprocal of the distance of the image, is equal to the reciprocal of my focal distance. Now we're trying to find distance of image, so I'm going to have to rearrange this. I get 1 over distance of image is equal to 1 over my focal length minus 1 over the distance of my object. One thing here. What kind of lens is this for my focal length? This is diverging, so that means my focal length must be negative because it's going to be on the same side of when it's diverging, my focus. So it's negative. Okay, now let's continue this here. I'm going to end up getting 1 over 5. So we get 1 over negative 5. See? 1 over negative 5, and then I'm going to minus 1 over 10. Which is going to give me 3 over 10, and that's negative. So I end up getting, so that's 1 over di. So my distance, now I can finally take the reciprocal, is going to be 3.3 centimeters, and that's negative. So now we're going to try and figure out what is my height. Well, if you remember, our heights are proportional to our distances. So I know my height of image divided by my height of object will be the same as the negative of my distance of my image divided by my distance of my object. So in this case here, we're trying to find my height of image. So we have height of image is equal to negative distance of image multiplied by height of object divided by distance of object. So now let's plug in everything we know. We know my distance of my image is 3.3. So we have negative 3.3. And that's going to be multiplied by my height of my object is 2.5 centimeters. And that's all divided by my distance of my object is 10 centimeters. And once we do that, I'm going to end up getting 0.83, and this is positive. All right. So now let's figure out what the attributes are. So since my distance is negative, This means I am virtual. Okay, so that means we are virtual. Now, I look at this here. My height is a positive, and since it's positive, that means we are erect. Now, I look at my height here also. My height of my object is, or of my image, is smaller than the height of the object. So that also means we are diminished. So here are some problems for you guys to do. I'm going to let you guys copy these down, and the last question looks more like this. And then I want you guys to do an attachment that is in the Google Sites.